Hello. I gave you this question at the end of the previous video. And so the t statistic was minus 1.5. And let's think one by one. If the if the significance level was 10%, the cutoff was 1.28. Actually, you have to think it as minus 1.28 because you are only considering the lower tail, so the cutoff must be negative because it is negative tail. So the cutoff is minus 1.28, and the observed t statistic is smaller than minus 1.28. Then you are going to reject the null hypothesis. In this case, yes, it is rejected. T is minus 1.5, which is lower than minus 1.28, which is the cutoff at 10%. So it has to be rejected. It is too small, even smaller than the cutoff. So 10% rejects. How about 5%? 5% cutoff is minus 1.64. So you are going to reject observations if t statistic is smaller than minus 1.64. So we are rejecting lower tail, or we are rejecting if the observation is too small. But how small is too small? At 5%, smaller than minus 1.64 is defined as too small. So in this case, minus 1.5 is not too small. It is greater than minus 1.64. So 5% cannot reject the null hypothesis. So that means automatically 1% cannot reject it, right? As the significance level decreases, the rejection is less likely. So once you cannot reject at 5%, then it automatically implies you cannot reject it at 1% or at any lower significance level. So the answer is A. Only 10% can reject it, right? So the mechanism is the same, but the only difference is one direction and different cutoff value. That's the difference in one-tail test. So now let's compare. In this case, I said you have to take negative number because you are only caring about the negative side. So now briefly compare the numbers. When you had two-tail tests, suppose when alpha is 10%, then this means 10%, you are rejecting 10%, but the 10% is from the bottom and from the top. So I have and the probability 10% will be split into half. So you are going to reject top 5% and bottom 5%. So the threshold should exist for the bottom and for the top, and it is basically the top 5% value. Top 5% value is 1.64, so you reject value is greater than 1.64, and then, which is 5%, and then you are going to reject the bottom 5%, which is smaller than minus 1.64. So that's why you have z alpha over 2. It implies that top alpha over 2 probability value, in this case, alpha is 10%, so this is top 5% value because you have to split 10% into both tails. So you get 1.64. And because it is top 5% value, in one tail test, it is used at 5% significance level. So when you use 5% significance level, it only rejects bottom 5% or top 5% only on one side. So in that sense, one tail test 5% has the same threshold as two tail test 10% because it's about top 5 or bottom 5%. And compare two tail 10% and one tail 10%. One tail 10% threshold is smaller, right? 1.28. So in this case, you are going to reject if the sample mean is greater than 1.28 or not, like greater than 1. No, excuse me. So in our example, we are going to reject the null hypothesis if the t statistic is smaller than minus 1.28. Smaller than minus 1.28 is too small. But previously, too small was defined by minus 1.64. So as you saw, for example, minus 1.5 is not too small in here in this sense, but it is too small in this sense. So negative, there are more rejections on the lower tail when you use one tail tests. Right? The idea is again, you are rejecting the whole 10% only on the lower tail. But on two tail tests, your 10% is split between the bottom tail and the top tail. So if you just look at one side, one tail tests reject more outcomes, more from one tail. So now let's think about the critical value. T-statistic approach was considered, and now consider the critical value approach. First, you have to think about is you have to consider which direction you are rejecting. When you have these hypotheses, as I explained, you are going to reject the null hypothesis if sample mean is too small, right? That is clear from this inequality. The inequality in the alternative hypothesis implies that you have to reject the null hypothesis when the sample mean is too small. So it looks like this. You just need to find this critical value, and there is only one critical value, and which will be smaller on the smaller side. So for this lower tail test, critical value is mu0 minus z value times standard error. So point here is it must be smaller than mu0. Here is mu0, and you are going to reject if the observation is smaller than a certain point, which is even smaller than the hypothesis. So you accept up to this much, but reject from here. In our example, it is easy. We know how to do it. One more thing. Z value here uses alpha. This alpha is, so Z alpha is different from Z alpha over 2 we used for two-tail tests or confidence interval. So this is different. If you use 5% significance level, you have to use 1.64 because it is one tail. This is the top 5% value. But previously, we used to use 1.96, which was top 2.5% value. So 1.96 was used for confidence interval and two-tail test, but now you have to use 1.64. So the intuition is the same, as I said. It depends on whether you look at only one tail or both tails. As if you choose a correct number for correct value of the z alpha, then everything else is the same. Is simple. mu0 is your hypothesis. You know the number, and 3 pounds. And standard error is 100. It's easy. Then you get 2.836. Then, and remember, we observed 2.82 as the sample mean. Then can you reject the null hypothesis in this case or not? Think about that. Consider so. So I'm going to stop the video here and think about this and continue, resume in the next one. Bye.